So in today's class, we will solve some numerical on velocity, potential function, and stream functions. So before that, what we'll do, we'll make a list of formulas. It will help for solving the numericals. The first point, what I will write is list of formulae, the different formulas for solving numericals. So velocity potential function will be represented by a symbol that is phi. The stream function will be represented by a symbol psi. Okay. Then by definition, the partial derivative of velocity potential function with respect to any one direction is equal to velocity in that particular direction. Here I have taken the direction x, so velocity in x direction is u, and it is a negative derivative. This is the one formula. Similarly, for y direction, the negative derivative of velocity potential function with respect to y direction is equal to the velocity component in y direction is v. And similarly, the negative derivative of velocity potential function with respect to z direction is velocity component in z direction, that is omega. So this is three formulas. The next is formulas for stream functions. Stream function is represented by symbol psi. Then what is the definite formulas for stream function is the derivative of stream function with respect to any direction, which gives the velocity component perpendicular to this direction here. Perpendicular to this direction, x is direction I have considered. Perpendicular to x direction is perpendicular to x is y. So velocity component in y direction is, that is v. So v is here with negative sign. Okay, and similarly, one more formula, partial derivative of stream function with respect to y direction is equal to, here I would consider the direction y. So y is here, that is perpendicular to y axis is x axis. The velocity component in the x axis is, that is equal to u. So u is the formula. And there is no formula or equation or partial derivative equation for stream function along z axis, because it is a two-dimensional flow only. So only x and y, there is no z axis is considered. So these are from formulas. One more formula, I will write the Laplace equation. The Laplace equation for stream function, for example, for velocity potential function, first you will write the Laplace equation for velocity potential function phi is equal to dou square phi upon dou x square plus dou square phi upon dou y square is equal to 0. So what is the significance or purpose of this Laplace equation is, in the question paper you will be given the value of phi. It is not a value, means it is not a definite number, it is a function of some x, y, some equation. So you need to calculate the derivative of phi with respect to x as well as derivative of phi with respect to y. Substitute in this equation. So if you got equal to 0, then it is a case of fluid flow. Case of fluid flow. For 4 marks or 5 marks it will be asked. Or if it is not equal to 0, then it is not a case of fluid flow. Okay. Similarly, the Laplace equation for Laplace equation for stream function psi is equal to dou square phi, not phi here, psi divided by dou x square plus dou square psi divided by dou y square is equal to 0. Again, the same fundamental concept you apply here. So if the function psi, if it after deriving derivative of both x and y direction, if it is equal to 0, then it is a possible case of fluid flow. Possible case of fluid flow. Dear friends, here I have considered only two direction here. Here is also considered two direction. Here is also only two-dimensional flow. Oh, but in advanced courses, you may ask for three direction also. So one more term will be added in the Laplace equation. Here there will be plus dou square phi upon dou z square will be added. Depends upon the type of function he has given in the question paper. But for Laplace equation for stream function, it is only two-dimensional. It is not three-dimensional flow. So these are the some functions formulas required for solving the numericals on velocity potential function and stream function. So we'll take one previous question paper. So this is a question paper I have taken June, July 2019. So we are solving numericals on module number 2. Here is a module 2. Then first part, explain different types of fluid flows with examples. This theory topic we covered already. There are different types of flows like steady flow, unsteady flow, laminar flow, turbulent flow, one-dimensional, two-dimensional, three-dimensional flow, rotational flow, irrotational flow, and there are all the types of flow, uniform and non-uniform flow, also one type of fluid flow, and it is asked for 8 marks. So this theory topic we covered, and the video lectures on these theory topics are available in the video description box. The link is given. Click on the link and you can watch the different types of flow. The second question, question number 3b, derive the continuity equation for a three-dimensional flow in Cartesian coordinates. It is asked for 8 marks, as it is important question as well. It is asked many times, and the video lecture on this topic is also sent to you, and it is available. The link is available in the video description box. You click on this link, you can watch the derivation of continuity equation. And the third question we'll see, question number 3c. All of you read. A stream function is given by psi is equal to 3xy. So one function he has given, that is stream function. So for this stream function, determine whether the flow is possible or not, and it is only for 4 marks. Okay, so how will you check, and or what is the condition for determining any function whether flow is possible or not? The answer for this question is we need to write Laplace equation. If the given function, if this is a function, if this function satisfies the Laplace equation, then it is a case of fluid flow or flow is possible. If it is not satisfied the Laplace equation, then you can say it is not a condition for flow is possible. It is not flowing. Okay. Next, what I do is I will write the given data. We'll take the question paper here. Yeah, this is the question. So first you write solution, given data. So first, what are the step you need to is identify what type of function is given, whether it is velocity potential function or whether it is a stream function. So in the given question, it is a stream function. So write stream function will be represented by the symbol psi. Anyway, it is given in the question paper, but in some questions they will not give the symbol directly, they will give the equations. So phi is equal to 3xy. So determine whether the flow is possible or not. The condition the condition for flow is possible or not, then it would satisfy Laplace equation. Laplace equation. So we have written some formulas just here. This is the Laplace equation. So I will copy the same equation and I will write here the Laplace equation for stream function psi is equal to dou square psi upon dou x square plus dou square psi upon dou y square is equal to 0. You take this is equation number 1 and this is equation number 2. And dear students, now I need a second order differential derivative term in both with respect to x and as well as with respect to y. So differentiate equation number 1 with respect to x. So please do it. So step number 2, here is a step 1. The step number 2 is, so dou psi upon dou x. So differentiate this equation with respect to x. So what I will get here, it is 3y. Okay, I need a second order. Again differentiate this equation with respect to x, with respect to x. So what I will get, dou square psi upon dou x square. What is the differentiation of 3y with respect to x is equal to 0? Because 3y, y is not a function of x. It is different function. It is a different variable. If in this position, if any term with x is there, then we could have differentiate. But here it is y term is there. It is not a function of x variable. So it will be treated as a constant. So differentiation of constant is equal to 0. So you can take this is equation number 3 or not necessary. It is a simple. So similarly, you calculate the differentiation term of with respect to y. So I will write here the differentiation or derivative of partial derivative of the stream function with respect to y. What is this function he has given? It is 3xy is a stream function. So the derivative of stream function with respect to y. So differentiate this equation with respect to y. What will get? It is 3x. Again differentiate with respect to y, because I need a second order derivative. So here again this will be treated as a constant, because here it is x is there, it is y. So dependent variable should be y. So 3x is considered as constant. So differentiation of the constant is equal to 0. Here we got dou square psi upon dou x square, and here we got dou square psi upon dou y square. Substitute these two in equation number 2. This is the Laplace equation. Substitute these two in equation number 2, then we can find condition of flow. So from equation number 2, dou square psi upon dou x square plus dou square psi upon dou y square on the both left hand side as well as on the right hand side, you will get 0. Both will get 0. So it is a possible case of fluid flow. You can write here, hence it is a possible, or flow is possible. Flow is possible, or it is a possible case of fluid flow. That also you can write. Okay.